Sparklines are a great way to add visual elements to your table. And not only does this add a bit of visual appeal to your table, it also makes your table more informative. For example, you could highlight the evolution of a stock price over time with a sparkline. In fact, that is a typical use case of a sparkline, and in this video I'm going to show you how you can add any sparkline to your table in R with the GT package. In my quarto file, I've already put in a code chunk that loads the tidyverse and also two datasets from the Tidy Tuesday challenge. Let's execute all of this, and when the data is downloaded, we can see that the first dataset, this one here, it shows you stock data for different kind of stocks. Now, if you're anything like me, you won't know what AAPL stands for, so this is why there is the second dataset that shows you what the stock symbol AAPL stands for. In this case, it is Apple. Now, the first thing we should probably do is to put these two datasets together. So let's just take the big tech stock prices and pass this to left join, where we use the other dataset. And then we tell the left join function to join these two datasets by the stock symbol column, because we can see that both of these datasets have this exact column inside of them. So we can join by them. And if we execute this, we have all of the datasets put together. We can see here now that there is this company column inside of the dataset. But now we should probably only focus on the columns that we are interested in. So in this case, that is company, date, and open. And now that we have this dataset, let's save this into a new variable so that we can work with that. This dataset has still a lot of rows, and if we want to put all of that information into a table, we have to summarize it somehow. So let's make a new code chunk, and in there we can put in our code for the summary. Here, this means that we take the dataset and then sort it so that it is sorted by date. In this case, it is actually already sorted that way, but we have done this manually so that we can really be sure that everything is sorted by date. And the reason for that is that in our summarize call, where we want to compute the relative change from the first record to the last record with respect to the opening prices, we want to know which one are the first and the last, and that's why we arranged by this date column. And now that this is arranged like this, we can simply use the open column and then from there get the last entry. So this is why we use open bracket length open here. This is why this is there. And then we divide this by the first value. Now, to make sure that we actually compute the change, we have to subtract -1. That's just how these percentage calculations work. And then we have to make sure that we do this calculation for each company that we have inside of our dataset. Notice that, in fact, our sorting did have an effect. It is now showing Apple, Adobe, Amazon, Salesforce, and so on. So for all of those companies, it shows you the first entry, and then it shows you the next entry for all of the companies again, and so on. So this was the effect of our date here. I actually didn't see in the first time that this is a different sorting than the one we have here. In any case, now we do want to compute all of this stuff with respect to each company. So this is why we use the .by argument to do group calculations. And then if we execute this, we get the relative change of each company. Now in a table, it will be helpful if these values in the relative change column are sorted somehow. So let's arrange this. Nice. And with that, we can save this into a new data set. Let's call it rel changes. Now with this dataset and the GT package, it's really easy to create a nice table by first calling this new package GT and then simply taking this dataset and passing it to the GT function. And if we execute all of this, we can see that we get a table just like the data that we had here. It's exactly the same thing, but it is printed it in a table format. Let me actually move this down a little bit so that we can see both of them on top of each other. Also, let me make a little bit of room here so that I can throw in additional code changes in here and you can see that better. Now the column names in our table are exactly the same thing as in our data set. For a data set, these kind of cryptic names are fine, but in a table, that's not really what we're going for. So let's make the columns nicer, and we do that by passing the table to the calls label function, and in there we can simply specify the new names for the original columns. And that way we can see that we have new column names. But we should also format the values that are inside of the dataset, because these are percentages and it's kind of hard to tell that we want to talk about relative changes here. I mean, you could probably guess it from the way these numbers look, but still, let's make it really obvious by actually putting percentages in there. And that's why we take our table and we pass it to the next function, namely the format function fmt underscore percent. There are a lot of fmt underscore function depending on how you want to format some columns. But of course, you have to tell this function which columns that you actually want to format. In this case, it is the rel change column that we want to change. And it's really easy to see now that some companies had really huge changes from the first date to the last. I believe in this data set it is from 2010 to all the way to 2023. So that's really a long time, but still a huge growth. This data set only shows us the information of the start and the endpoint, basically. It's the relative change from the first date to the last date. But what make this table more informative is if we had a sparkline here that also shows us the way the open price evolved. And we can make that happen, but the first thing we need to do is to get this information of all the values that this open column had in between. We need to get this into our data set rel changes. Right now it only has these values, and these are the things that are inside of the table. So that's why we need to modify our summarize call, and in there we add another line where we say the open prices are just the list of all the open prices you find. And that way, if you execute this and then look at the data set, you see that each company now has another column, or rather has another cell in here that has all of the information stored as a vector. You can actually see here that for the Meta company, you see that there's less data than for the other ones. So that way you have the information of the evolution of the open prices inside of this data set. But look what happens if you try to re-execute our code from before. This is a mess. You get all of that information, all the prices just printed into the table, and this is not something we want, so we have to modify this somehow. Thankfully, the GT Extras package has a function that makes it really easy for us to turn this mess into a nice picture. And the way to do that is to simply take the data and pass it to some function from the GT Extras package. And in this case, it is the GT Sparkline function. And if you execute this, it will complain that you must select at least one column, not at least exactly one column. So if you do that, if you tell this function that as the column that you want to have, you use the open prices, then you get a nice image that looks like this. Though it is a little bit flat, so we should probably change the dimensions of this image here. And the way to do that is to first make some room here, and then we can add the additional argument called figdim, which will, well, change the figure dimensions. And if we execute this now, we can see that these images changed, and now we can see more of the evolution of the stock prices here. Notice that you can always play around with these values here. For example, if you want to make the line chart wider, you could modify the value here, and then the line chart would get wider. Similarly, you could change the height by changing the first number, and that way you would have a larger image again too. It works the other way around too. You could also make it flatter, but really I like that it shows more of the evolution of the ups and downs if the image is larger. Okay, so this is how you really easily add sparklines to your table. Basically, it's only about calling this function from the GT Extras package. And before you can do that, you have to get your data inside of the data set so that it is inside of the column and one cell for each of the opening prices. Notice that here it was crucial to use the list function to really stick in the numbers into one cell each. Otherwise, the summarize call will try to create one new row for each entry in the open vector. That's not what we want. The list function makes sure that everything goes into one row. Nice, and with that we're done. Hope you enjoyed this video. As always, you can find all of the code in the corresponding blog post. Thank you for watching and see you next time.